All right, here we go. We got a couple little kitty cats with us with giant question marks over their heads, wondering what I'm about to throw at you. You guys probably are too. We are going to talk about the point-slope form of an equation and writing equations of lines perpendicular and parallel to a given line. So that is a lot to ingest right off the gate. All right, here we go, guys. First, let's start with a formula. And you guys are very accustomed to this formula, right? You guys have used this a lot. Y equals mx plus b. And we know that, of course, our m value is going to be our slope. And our b value is going to be our y-intercept. And magically, this is why this formula is called the slope-intercept form of the function. Okay, so also magically, when we're working with the point-slope form of the function, we need a point. And we're going to call that point x sub 1, y sub 1. So it just stands for any xy point that's on our line. And we need a slope. Imagine that, point slope. So we'll just designate it with the variable m as we have in our previous formula. So here it is. It is y, so keep that y, minus y sub 1. This is the y sub 1 we're going to replace with a coordinate, is equal to m, your slope, times x, we're going to keep that x, minus x sub 1, we're going to replace that x sub 1 with a coordinate. Okay, so the values that are getting replaced with numbers in order to create this point slope form of the equation are your y sub 1, that's going to get replaced with a number. Your slope is going to be identified and that's going to become a number, and your x coordinate is going to go right into that spot. Okay, so we're just going to do a little practice here, one with parallel and one with perpendicular. Okay, so we've talked a little bit about parallel lines already in class, and we know that one of the key things for parallel, right? So if we know we're going to have lines that are parallel, we know we are going to have the exact same slope. Okay? Exactly equal. So for writing an equation through -2, 4, parallel to y is equal to -5/4 x plus 1, we will first identify the slope. So my slope is equal to a -5/4. And I will also identify my point that I'm going to be using. And the point that I'm going to be using is given right here. It's -2 and 4. And then I'm going to place all of these numbers into my formula. So here's how it's going to look. It's going to look like y minus my y coordinate. So here's my y sub 1. So I'm going to plunk a 4 down right there, is equal to m, which is my slope. Here's my slope right here, my little m value. So -5/4. And then in parentheses, x minus, and here's my little x sub 1 value, and I'm going to subtract a -2. Now we can simplify this farther, or we can, instead of writing x minus a -2, we can actually write x plus 2. And if you want to take it even further, you could distribute your slope and add 4 to both sides and convert it from point slope form to slope intercept form. But really, I'm not interested in you guys having to do that part of it right now. What I want you to get used to is I want you to get used to using the formula, using your slope, using your point, identifying parallel lines with the same slope, and then we're going to move on to perpendicular lines here in just a minute. Okay, so remember, these parallel lines are going to have the same slope. that -5 force parallel. Right here you can see the slope of this line is 5. So if you were to try question number 22, you would use 5 for your slope. Okay, hopefully that's making sense. Let's do one more example. I'm going to keep my formula right there so I can actually see it. And we're going to try 24 here. So this time we want perpendicular. Okay, we want something that is going to be perpendicular to this given line. Okay, so a little note about things that are perpendicular. Let's change up our color here a little bit. Okay, so if you have perpendicular lines, they are going to have slopes that are negative reciprocals of one another. And those are like really big vocabulary terms to kind of keep straight. So one of the things you can do is just imagine an example, like if you had 3/5, the negative reciprocal would make it negative, and reciprocal means you're going to flip your fraction. So your new slope would be -5/3. So I always start with saying, what is my slope? And then what is my new slope? Because they're not the same for perpendicular lines. Okay. So you got to pay attention to that as we're working on this. Everything else kind of stays the same. Okay. So point slope. Let's grab our point. Our point is the point right here. -3, -1. That is our point. Our slope, okay, is 2, right there, 2/1. But because we're talking about a perpendicular, we need to find our new slope. Okay, what is our new slope going to be? Our new slope is going to be the negative reciprocal of 2/1. That's positive now, so we're going to make it negative, and we're going to flip our fraction. So it's going to be -1/2. So let me share with you where these variables are going to go, right? This is going to be your x1. This is going to be your y1. And this number over here, -1/2, is going to be our slope. So let's plug everything in. Here we go. So it's going to be y minus my y1 is -1 is equal to my slope, -1/2, times x minus my x1, there it is, -3. I'll put that right in there. And now that I have everything in place, I can simplify a little bit more. Subtracting a negative means y+1. And again, if you decided that you wanted to distribute and continue with this equation to change it into slope-intercept form, you could sure do that. Otherwise, this is it. That's your equation. So we've done one that is perpendicular, we've done one that is parallel, and hopefully that will be a good start to this unit for you guys. All right, guys, hopefully that's helpful, and we'll go over more questions in class. See ya.